Hi, my name is Kurt White, and I'm a medical device researcher at the Child Mind Institute Matter Lab. And I'm going to share with you our system for prototyping small devices, namely wearable devices. We use these for both gathering data and as clinical interventions. I'll go over that a little bit more later. But first, um, hacking activity trackers. So this right here is an X9. It has an NRF52832 system on a chip from Nordic with an ARM Cortex M4 MCU. Color display, organic LED, has an accelerometer, has flash memory, touch sensor, vibration motor, and obviously the strap and a nice little metal enclosure. This is the device that all these tutorials are going to focus on the most. I've included Arduino example code for the display, for using serial Bluetooth for debugging, also web Bluetooth, or rather code that will allow you to interact with a website or web application with web Bluetooth, and simple stuff like a blank sketch and using the button. You can, if you know how to use Arduino, there isn't much of a step up to using these things. It's just a matter of kind of using a different programmer, SWD. There's lots of instructions that I've included about how to do that. I find these things extremely useful. They're incredibly inexpensive. This is $35 for everything that I just mentioned. And I think that there are a lot of people out there who will find this really useful. If you told me I was going to be building things with a hacked activity tracker from China a couple of years ago, I would not have believed you, but these things are great. I think you'll like them a lot. So in terms of, oh yeah, before I get any further, so this is what the X9 looks like kind of out of the box. This one's hacked, but it looks the same. And here you can see the cap off, and you'll see that it's all wired up. So honestly, these things wouldn't be useful if I couldn't add stuff to them. That's the whole point. So then the question is, how do you get additional pins, additional GPIO, general purpose input output, when it's all tied up in the device and what the device is designed to do. What I do is I cannibalize. Usually I remove the display and anything else that I don't need, and I'll just use the pins from that, and it works really well. I've included instructions for that as well. In terms of what I use these for at Matter Lab, I'm just going to go over this really briefly, but I'll give you a more detailed explanation with demonstrations later. This, just first, the fanciest thing. This is we call this a thermo. These are pet names. What this is it's a position tracker. So with VR headsets like Oculus and HTC Vive, they come with controllers that act as position trackers. So you have the controller, you wave it up in front of you in 3D coordinate space, and you're able to control objects in virtual reality that correspond to your movements in 3D coordinate space. Now, those require a camera. You have to have an external reference point. So you have the controller, and then you have a camera, and the Oculus or the Vive knows where your hand is by basically figuring out the relationship between the camera and the controller. This does not do that. This is standalone. So the idea is to get the equivalent functionality of the Vive and Oculus controllers without a camera. So you could just walk around the street, and you'd have this on, and you could interact with the environment around you in virtual or augmented reality as if you were using an Oculus or a Vive controller. And the gist of it is that it uses thermal data to do what is essentially image recognition on the body using neural networks. Pretty cool stuff. It's a neat little project. We don't have any direct application at the CMI right now. We have been talking to some people who are working on sign language recognition. And these people are using a camera mounted on the wrist. And that camera would do image recognition on the fingers as the fingers moved. So that covers kind of half of American Sign Language. But of course, a lot of sign language is arm movements, really big arm movements, and a wrist-mounted camera isn't going to cover that. So the idea for a collaboration with the sign language translation research team was that they could combine the two. So you'd have this position tracking device using this hacked activity tracker, and you'd combine it with the wrist-based camera, and then you'd have a whole system. And it's a fun research project, but it's not the kind of thing that I would expect to actually start helping people in the near future, which is what we're all about. On a more practical note, this is the Tingle, also our pet name. And what this is a gesture recognition and biofeedback device. And this is targeting compulsive behaviors in children, namely trichotillomania and excoriation. But it could be any number of other compulsive behaviors. Trichotillomania is compulsive pulling of the hair. Excoriation is compulsive picking in the skin. It doesn't sound that bad when you say it, pulling hair, but the reality of that disorder is gruesome. And it's really tragic to see that in children. So the way that this works is you wear it on your wrist like this, like so, and you train it to a particular problem area. So let's say I'm pulling out the hair on this side of my my head right here. Basically, the device would be able to detect when I'm trying to pull out my hair here, and it would set off the vibration motor, which is already there because of the activity tracker. It would set off the vibration motor to alert me that I'm engaging that behavior. Remember, these are compulsive behaviors, but people are doing this unconsciously. They're initiating the behavior without even knowing they're initiating the behavior. So the idea is that you'd be able to intervene before it actually happens. It's a matter of kind of adding awareness. Now, in addition to that kind of direct biofeedback clinical intervention aspect, we're also gathering data. So all of the users' behavior in relation to how they're using their hand is going to be recorded. So we would know when they're engaging that behavior, the circumstances, is it after they've had some kind of stressful encounter? Is it, when they're in the car, some kind of transportation? Is it before they go to sleep? Is it right after they get up? All that stuff is really useful to know, not just for that person, but for just learning about the disorder in general, for research, for learning more about how these things work. Maybe we can learn things about trichotillomania and excoriation through this device that will enable other approaches to emerge. It's not just about this particular device and that particular clinical intervention. Getting the data about how this disorder functions can help in a wide variety of ways, and not just at CMI either. We make all this data available to other research groups, other institutions, so that they can use it as well, which is pretty cool. And it's all on these hacked activity trackers. Who would have thought? And you can build stuff like this too. These devices are not that complicated, really, from an engineering perspective. Most of the fancy footwork is on the data end of things, in terms of kind of how we gather the data, how we process it, trying to incorporate a whole lot of data, gathering tons and tons of data, and being able to extract information about it, just kind of knowledge from that huge, vast amount of information, and crystallizing it in a way that we can leverage with these little devices, these little devices with their sparse little sensor configurations. That's the idea, and that's what we're doing. Oh, and before I move on to anything else, there's another device that's pretty cool. So this is using a NRF51822 activity tracker. This is an intraoral respiration monitor. So basically, it's a computer inside your mouth that measures not just your respiration rate, but the entire respiration waveform, which is more than could be said of just about any other technology that monitors respiration. So just to prove the point, there's one in the mouth like this. I know it works. I'll show you. I'll demonstrate it. It's pretty cool. So that was built with opiate overdose in mind. So naloxone, better known, I guess, by the brand name Narcan, is a miracle drug when it comes to overdose. Someone can be on the way to dying. They are gonna die, and you can give them naloxone, and it will pull them right out of it. Basically, naloxone acts on the same receptors in the brain as opiates, but it kind of kind of pushes them out because it acts on the same receptors, but is more dominant. It's able to push the opiates kind of out of the receptors that they're trying to engage in. The naloxone takes its place, and poof, the opiates are no longer having an effect on the brain, or at least not like that. And you're saving lives. So back to this thing. The only approved indicator for the administration of naloxone is depressed respiration rate. So you might be able to detect overdose any number of ways, but that's not going to add up to someone being able to authoritatively say that you can administer this medication. In addition to being able to monitor respiration, whether it's for clinical studies in a lab setting, or whether it's people walking around with these things in their mouth, obviously not this one, there's always the possibility that this could be used for automated administration of naloxone in addition to just monitoring respiration rate. So there are two different formulations of naloxone on the market. There's injectable naloxone, so that's going to be intravenous and intramuscular. And there's intranasal naloxone. So basically, it's this little plastic applicator, and you shove it up someone's nose, and you press down, and it shoots the naloxone up your nose. So that's going to be passing across the mucous membrane, and there's enough bioavailability with that formulation to make it work. It's naloxone. So interesting thing is, it costs tens of millions, if not hundreds of millions of dollars for pharmaceutical companies to get drugs approved by the FDA. So if a pharmaceutical company is going to spend all that money, they're going to try to get as much bang for their buck as they can. And that's exactly what the producer of the intranasal formula of naloxone did. So when they were doing all their clinical studies and doing all the stuff that they had to do to get their drug approved, they didn't just study intranasal naloxone, they also studied sublingual naloxone. So sublingual will be absorbed through the mouth. So it's also being absorbed across a mucous membrane. So it's very similar. In fact, with these studies, it's basically exactly the same. So there's no sublingual on the market, but a lot of the legwork, some people might say all the legwork, has already been done to put it on the market, which is a big deal when these things cost tens of millions of dollars, if not hundreds of millions of dollars, to get out into the real world helping people. So with this guy, back to the device, the idea is that maybe you could have a little cartridge inside of it with the sublingual naloxone, and when it detects an overdose using respiration as a basis, it would trigger a little mechanism that would eject the naloxone from the cartridge in the mouth, and there it would be absorbed through mucous membranes, and there you go. It's an administration of naloxone. All that's highly speculative. This device was presented at the NIH, the National Institute of Health, to none other than Norman Bacco, who's the top federal official for drug addiction and overdose. Pretty cool to get that kind of exposure. No grant money yet, but we'll see. You never know.